Modern surgery is a miracle of precision, but even the best trained hands can make mistakes. And in the operating room, mistakes can cost lives. What if I told you an algorithm, yes, just lines of code, reduced surgical errors by 40%? Let's talk about how. The story begins in a hospital system using thousands of hours of surgical video footage. Every incision, every suture, every movement, recorded, time-stamped, and analyzed. These weren't just training tapes, they were data. Using this massive dataset, researchers trained a machine learning algorithm to recognize patterns in successful surgeries and spot potential risks that even expert surgeons might miss. They called it a surgical risk prediction model. Here's how it works. Step 1. Real-time video analysis. The algorithm watches the operation as it happens. It tracks tools. It recognizes organs and tissues. It even monitors surgeon hand motion, speed, steadiness, precision. Step 2. Deviation detection. If the surgeon deviates from the safest pathway, or if an unexpected movement occurs, the system flags it immediately. But it doesn't just raise alarms, it learns from those deviations. Was that detour harmless? Did it lead to a complication? Over time, the AI builds a knowledge map of what success and failure look like. One of the most powerful features, it can now predict the likelihood of a surgical error up to 20 minutes before it happens. Imagine that. An intelligent assistant in the OR, watching closely, alerting the team before something goes wrong. Not reacting, but anticipating. So, where does that 40% come in? In a pilot program at a major medical center, surgeons used the AI tool during high-risk laparoscopic procedures. They followed the algorithm's prompts, when to slow down, when to adjust their approach, and when to double-check. The result? A 40% reduction in avoidable surgical complications. That's fewer injuries, fewer repeat operations, fewer lawsuits, and yes, more lives saved. And the best part? This tech isn't replacing surgeons, it's making them better. Think of it like a GPS for surgery. You're still in control of the wheel, but the system helps you avoid the potholes before you hit them. Critics argue that over-reliance on AI might dull surgical instincts, but early studies show the opposite. Surgeons using AI support actually improve faster over time because they're getting feedback in real time. And the AI, it keeps getting smarter. Of course, it's not perfect. It struggles with rare or novel procedures, and it depends heavily on the quality of the data it's trained on. But every surgery it watches, every error it catches, every life it helps protect, makes it stronger. So when we say this algorithm reduced surgical errors by 40%, we're really saying this is what happens when human skill meets machine intelligence. And this is just